Like we saw with our streams and how water is capable of both eroding and depositing sediment, in this video we're going to focus on how waves affect the sediment along our shorelines and how they move that sediment along. Depending on where we are, beaches around the world look very different from one another. And that's because beaches are just made up of whatever material is locally available. Here on the left, we're looking at the Sanibel Island in Florida, where the beach is made up almost entirely of shells and broken down shells. Because this is an area where we have a lot of shell-building organisms live. But if we were to go to Hawaii, for example, the image on the right is showing us black sand beaches. The reason the sand here is black is because of all of those basaltic volcanoes in Hawaii. So the beach, it's just going to be made up of whatever material is nearby. But this material doesn't stay in one location. We're going to see that the sand, or the shells, along our beach is constantly being moved around from one place to another. And the reason why it's being moved around is all due to that wave action. So as waves are coming through and breaking in our surf zone, they're going to literally start breaking the rocks and the sediments down. And as they become smaller and smaller pieces of rock and sediment, they're just going to start adding to our beaches. And we're going to see that most of this material comes from abrasion. An abrasion is kind of when we're grinding something down. You might have heard about an abrasion if you've been to the doctor recently, but if you fall and scrape your knee, that's an abrasion. You have grinded the skin of your knee against something and removed the surface of your skin. So we see that waves are really good at abrasion. They're going to grind down the surface of rocks as the water moves across it, and especially when the waves break against it. If we can look at the way that sand is moving along our shoreline, we're going to see that it actually moves parallel to the shore. And this is through something called a longshore current, which you can see in the image. The reason why we have this longshore current is due to multiple waves moving in and out. So if you look at this image, you'll see that the waves are coming in at an angle. They're moving up and towards the right, and then the wave itself is going to move straight back out. The next wave that comes in is again moving up and towards the right. When the wave goes back out, it goes back straight. But overall, it's going to create this zigzag pattern. And over a long distance, this is going to create our longshore current. The reason why we have this longshore current is due to the fact that as the waves are moving in from the ocean along our shoreline, they start to bend. And this is because they start touching the bottom of our seafloor, which is going to slow them down, causing them to bend. If we can look at the direction in which our waves are coming in and bending along our shoreline, we can figure out exactly which direction the longshore current is moving in. Because the waves are moving in, up and towards the right, our longshore current over multiple waves overall is moving towards the right. We might think about beaches as being these really long, straight shorelines, but most places we're going to see what are called headlands, and it's going to look like kind of a small peninsula jutting out into the ocean. And when this happens, it's going to cause the wave refraction to focus on that headland, that area that's jutting out. So most of our waves will break against this headland, meaning that the areas that are farther back are going to be protected from the waves. So over time, we're going to see that the waves are going to straighten this shoreline. Because they're mostly impacting the headlands, they're going to erode that first, and then generally over time, this will become a relatively straight shoreline, like we see here in Florida.